Naming acids can be summarized into 3 rules, and the rules depend on the anion ending in your acid. So the first example we're going to do is HCl. HCl, the anion, all acids have a hydrogen in the front, some kind of an anion, and an AQ subscript. The anion is chloride. An IDE ending gets changed. The IDE ending gets dropped and it becomes an ic, and we add a prefix to the front of hydro. Therefore, HCl is called hydro, the chlor stem word, and the ending ic. The name of the second acid in our table comes from an SO3 ion. An SO3 is sulfite, and the rule says we drop the ITE and add an OUS. Sulfur is one of 2 exceptions where not only do you drop the ITE, but you add the UR back in to make it sound nice. So it becomes sulfurous acid. Again, the rule is if it ends in ITE, you drop the ITE and add an OUS and the word acid. If your anion ends in 8, then you drop that 8 ending, in our example nitrate, and add an ic ending and the word acid. 3 rules. An IDE becomes a hydro in the same stem and the word ic. The ite becomes an OUS, and the 8 becomes an ic. Try to remember, I ate something icky. And now we'll do some examples that are not in your booklet. Number 1. By chemical formula, if I gave you this acid, say HNO2, similar to what we just did, but you'll note it's 2 oxygen atoms instead of 3. The ending for NO2 is what we need to know. Look it up on our polyatomic ion sheet, and we get a nitrite ion. The rule states if it's an ITE, you drop the ITE and you add an OUS ending. Therefore, the name of this acid becomes nitrous acid. ITE becomes an OUS. Another example, this time by chemical formula. Say we had this acid, H2CrO4 with an AQ subscript. The clue that would tell you this is an acid is dual. The AQ ending and the hydrogen ion in the front. So to name this acid, you need to look up, if you don't know, the name of the anion for CrO4. And that's a chromate. So chromate, the rule states, keep the stem chrome, drop the 8, and make it an ic. Therefore, this is called chromic acid. The H and the AQ is irrelevant to the name. It comes up, or I should say is explained really, in the word acid. Let's do a backwards one. This time I'm going to give you the name, chlorous acid. So we look at our name, we know it's an acid because of course it says it's an acid. If the stem ending is OUS, we remove that OUS and we rewrite it with an ITE ending. Therefore, we need to make up a chemical formula that contains the chlorite ion. Now chlorite is ClO2 with a 1- charge. Put that together with a hydrogen ion and you will get an H plus and a 1-. They are balanced. When you crisscross those, there's no need to add any subscripts. Therefore, your final answer would be HClO2 and an AQ subscript. That's the chemical formula that goes with the name chlorous acid. This time I'm going to give you a chemical name as well. How do we do this one? Permanganic acid. Could seem intimidating. We look at the ending. We see an ick. We do not panic. We say, okay, that acid must be made up with an anion that ended in an 8. If you don't know it or recognize it, go to your green table, your polyatomic ion sheet, and sure enough, there is an ion there called permanganate, and that's MnO4 with a 1- charge. Therefore, to make an acid, you have a 1+ charge. To balance the 1- charge, there's no need to crisscross and add any other subscripts. Therefore, your final answer will be HMnO4 with an AQ subscript. Let's do another one. This time we'll do it by chemical formula. So if we had H2 SeO4 appear in a chemical equation coming up in Chapter 7, how do we know it's an acid? Well, we certainly will recognize from now on that an AQ subscript in combination with a hydrogen ion means that it's an acid. To name an acid, you need to know the name of your anion. We look up SeO4 in our table. We see that it's selenate. The rule states that you take off the ending, what we call our suffix, 8, and replace it with an ic. Therefore, this becomes selenic acid. Not terribly common, but definitely something you should be able to name. Another one. This time we're going to do it by name. Hydrosulfuric acid. Hydrosulfuric acid. So the first thing that I see here is I recognize a hydro prefix in combination with an ic acid means that the acid is made up of an anion that ended in an IDE. So a sulfide ending, the UR in sulfur becomes in and out depending on pronunciation. A sulfide ion is a simple anion. When it comes together with hydrogen, it's not balanced 1-to-1. Therefore, you have to add a 2 subscript, and the final chemical formula becomes H2S with an AQ subscript to balance. Couple more. How about this one? Phosphoric acid. Phosphoric acid. So phosphoric acid should scream at you. An ic ending means it had to have been an 8. Phosphate is a very common ion. Remember the OR and the EUR of sulfur come in and out depending on the pronunciation. Phosphate's a 3- ion. When it gets paired up with the hydrogen, you will have to crisscross and end up with the 3 subscripts below your chemical formula for hydrogen. Therefore, the balanced equation, formula I should say, for phosphoric acid is H3PO4 with an AQ subscript. And that's the chemical formula for phosphoric acid. Another one. HCN AQ. Here are steps. What's the name of the cyanide ion? Oops, there we go. Gave you the answer. So it's a cyanide. CN is cyanide. The rule states an IDE ending, change the prefix in front, or add a hydro, keep the stem cyan, and add an ic. Therefore, this is called hydrocyanic acid. And one last one for the road. How about one that doesn't easily show up on the front of our ion sheet? IO2 is a variation on ClO2, and that ion is called chlorite. So IO2 is called iodite. The ITE ending converts into an OUS, so it becomes iodous acid. Hope this helps you to do some practice on naming your acids, and good luck.